Hello dear students of plus 2 medical and non-medical respected teachers. So today I am going to start the last unit which is known as electronics. So in electronics I would like to discuss first of all what are semiconductors, what is energy gap theory and what are the types of semiconductors. So first of all let us differentiate between conductors, insulators and semiconductors on the basis of band gap theory. So, according to band gap theory, there are two bands, one is known as valence band and another is known as conduction band. So, in case of conductors, this valence band and conduction band overlap each other. Means there are already some free electrons for conduction in case of conductors. So, conduction band and valence band overlap each other. Whereas in case of semiconductors, the conduction band and valence band are separated by a small gap which is of the order of 1 electron volt, and this energy is called energy gap. And in case of insulators, the gap between conduction band and valence band is of the order of 5 to 7 electron volt. So it means the energy gap is different for different materials. So on the basis of band gap theory, we can differentiate between conductors, semiconductors and insulators. So it means in case of insulators, energy gap is very large and there are no free electrons for conduction. So their conductivity is negligible. In case of conductors, there are already large number of free electrons. Conduction band and valence band overlap each other, so they have high conductivity. It means conductors have high conductivity and low resistivity. Insulators have high resistivity and low conductivity, and the semiconductors has conductivity and resistivity in between the two. So this energy gap, that is, what is energy gap? So amount of energy required to be given to an electron in the valence band so that it reaches to the conduction band, that is, it becomes free for conduction. So this energy required is known as energy gap, and for like semiconductors it is of the order of 1 electron volt, and for insulators it is of the order of 5 to 7 electron volt, and in case of conductors there is no gap. So energy gap is given by Eg is equal to h nu or hc by lambda. H is Planck's constant, c is speed of light, and lambda is the wavelength. So this energy gap is different for different materials. Then we define another term on the basis of energy gap theory, Fermi energy. So Fermi energy is nothing but maximum energy possessed by free electrons at 0 Kelvin. So at 0 Kelvin, the energy possessed by a free electron is known as Fermi energy. Then types of semiconductors. So basically there are two types of semiconductors. One is known as intrinsic semiconductor, another is known as extrinsic semiconductor. Now, in case of intrinsic semiconductor, when we take a pure sample of germanium or silicon, basically, pure sample of germanium or silicon, they are basically semiconductors. For example, germanium 32 has this configuration 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2 and 4p2. Similarly, silicon 14 has configuration 1s2, 2s2, 2p6, 3s2 and 3p2. And we see clearly, it is clear that both germanium and silicon has 4 valence electrons. That is, they are more stable, they pair even number of valence electrons. Now, so what happens in case of intrinsic semiconductors? So this is germanium, say it has 4 valence electron, it forms 4 bonds with the adjoining 4 germanium atoms, and this process continues in the sample. These are the germanium atoms, and each remaining atom form 4 covalent bonds with the 4 adjoining remaining atoms. Now then, due to thermal agitations, I've said due to temperature, energy of electrons increases. So thermal agitations, a few electron may become free for conduction. For example, this electron gains some energy due to thermal agitation and become free for conduction. But at the position of free electron from where it has gone to the sample and becomes free, a deficiency of electron is created, and this deficiency of electron is called a hole. And this hole can be filled by some other electron from some other atom, and this process continues. At this point, hole is created when this electron fills this hole, and this process continues. It means electrons and holes, they move in opposite directions, different and opposite directions. So it means due to thermal agitations, flow of free electrons starts, and that's why it starts conducting. But conductivity of pure semiconductor is very, very small. So when such a sample is connected to a battery or cell, then electrons and holes flow starts, and the direction of holes give the direction of current because it is opposite direction of flow of electrons. But conductivity is very, very small. So intrinsic semiconductors conductivity is very, very small. To increase or to enhance their conductivity, we make use of extrinsic semiconductors. So extrinsic semiconductors are also known as doped semiconductors. So the pure sample of germanium or silicon are doped with some elements, and this process of adding impurity to the pure sample of germanium or silicon is called doping. So doping is of two types. So therefore extrinsic semiconductors are two types, N-type semiconductors and P-type semiconductors. Now what is the difference between N-type and P-type semiconductors? In case of N-type semiconductors, when a pentavalent impurity means having 5 valence electrons like antimony or arsenic, is added to pure sample of germanium or silicon like this, is added to pure sample of germanium or silicon, then it increases the concentration of electrons in the sample, because out of 5 valence electrons of antimony, it forms 4 covalent bonds with the 4 adjoining germanium atoms, but 5th electron is loosely bound and becomes free for conduction. It means concentration of free electron increases by adding pentavalent impurity, and there will be few holes also. One electron may get free due to thermal agitations and another hole is created at this point. But electrons will be the majority carriers in case of N-type semiconductors, whereas holes will be the minority carriers in case of N-type semiconductors. Impurity atom is called donor because it donates electrons for conduction. So in case of N-type semiconductors, when a pentavalent impurity is added to pure sample of germanium or silicon, then the sample so formed is called N-type semiconductors. It's also called negative semiconductors, but it is not charged, just it increases concentration of electrons, because we are adding antimony atom, which is neutral. So N-type or P-type semiconductor is not charged, they are neutral. Then in case of P-type, when a trivalent impurity like indium having 3 valence electrons only is added to pure sample of germanium or silicon, again this indium forms 3 covalent bonds with the 3 adjoining germanium atoms, and there is a deficiency of electron, that is a hole is created. There will be few electrons also. So from where electron is removed due to thermal agitations, another hole is created. So it means in case of P-type semiconductor, when a trivalent impurity is added like indium, it increases concentration of holes. So holes are the majority carriers in case of P-type semiconductors, whereas electrons are the minority carriers in case of P-type semiconductor. And the impurity atom is known as acceptor. So this is the difference between P-type and N-type semiconductors. Again I repeat, in P-type semiconductor, we add trivalent impurity. In N-type, pentavalent impurity like arsenic, arsenic or antimony. In case of P-type, trivalent impurity, that is indium. In case of N-type, majority are electrons and minority are holes, and the impurity atom is called donor. In case of P-type, majority carriers are holes, whereas minority carriers are electrons, and the impurity atom is called acceptor. So this is the basic introduction of semiconductors and difference between conductors, insulators and semiconductors. So in the next video I will discuss electrical conductivity of a semiconductor. So till then, stay tuned, good luck, all the best, be happy.